Thank you, Rahul. Just give me one moment, sharing the screen. Oops. Okay. So there we are. So close this one. Okay. Your logging is here. This one. It's a cloud. Okay. So let me come here. This is part 2. Okay, so let's see where we are. I think we created a cluster yesterday, and we were looking at a managed node group scenario. Create the cluster, node group type. One moment, guys. Managed. Rahul, I don't think I have any theoretical slides. Maybe you can share your screen and try to bring up the cluster that we created yesterday, the EKS cluster.
Okay, sir.
Directly get into labs. I think in US East 2, I think we created a cluster, Rahul, from what I recall.
Yes, yes.
Sit. Can you just take a look at the history also?
Yes.
What is it, Rahul?
Yeah, I'm checking this whether the server was right or not. Yeah.
Engines from 1.6, replicas is 5. Okay. And I think from what I recall, we created a M3 large or M3 for EKS cluster because we were having
Yes.
M5 large. There you go. Okay, so we're on the right track, and we created a cluster. Then we applied the nodeport.yml.
Yes.
And we're also looking at the replicas. Okay, that is and the ports. Okay, scroll down, please. Node group. Okay, so I come here. Can you do get clusters? EKSCTL get cluster or get clusters? I think it get cluster, I think 108.
Okay. 10.
I'm not getting it. Have you deleted the cluster that we created, the EKS cluster we deleted, I'm sorry, we created yesterday?
I don't remember. Maybe we have deleted, I guess. EKS cluster, yes, we have deleted this one.
Oh, okay, we deleted, we did. Okay, interesting. And then I see again, we are doing a node group cluster EKS test 2, get pods are white. Okay. I think we're just making sure.
Should I verify our dashboard also whether it is there on?
No, if CLI, it says it is there. It should be deleted, right?
Yeah.
Okay. Okay, the next one is going to be Helm, but before Helm, there is one scenario. I'm just verifying it. Rolling update. Okay, let's give it a quick try. Can you type in EKSCTL? Create cluster hyphen name. Let's call it EKS. Let's say EKS rolling. EKS rolling. And let's give it a version hyphen version 1.14. And we'll use a hyphen node group name. Node group name. The hyphen node group name, one word. We'll say EKS nodes. That's going to be the name. And we'll use a node type hyphen node type. Node type. We'll use a t3.micro. T3.micro. And hyphen nodes is four nodes. Hyphen nodes. And space hyphen managed will have the workers also managed by the AWS. Hyphen managed. Yeah, press enter. 1.14 is not supported. Supported values. Try bring up the same thing, change the version to 1.16. I know it's giving me error message, but 1.16. I think we'll get there. Specifically. Okay, change it to 1.19. Okay, let's give it a moment. I think this will take a little bit of time. In the meantime, while that is coming up, let me come back here. I'll give you a quick overview of Helm.
Should I stop now sharing?
Pardon me?
Should I stop sharing?
Hold on one moment, please. Okay, that is Helm. Scroll on here. You can stop sharing now.
Yes.
So let me give you a quick overview of the Helm charts. So as the name suggests, it says Helm and charts. Helm is really a package manager for Kubernetes. Chart is really a package here, like we have discussed about the modules and the packages in Python. Even though it says charts, it does not have anything related to the charts. They just named it as charts. And so what we are doing is many of the steps that we are doing in Kubernetes have multiple steps. So the Helm allows us to do all the multiple steps in just one or two steps. That is what is important. And there it has developed its own ecosystem of other kinds of packages which are referred as charts. Using these charts, we save a lot of time and we save a lot of other nitty-gritty details, and the complexities also is what it is. So short and sweet, Helm charts have nothing to do with the graphical charts of the dashboard. So here is a scenario, a typical three-tier architecture. We would have a UI, a front end. Then we would have the business logic or the business layer, which is in the web server. And then we would have the database layer. So that's like a 3-tier architecture. So ideally what we're doing is for doing the load balancing, we apply web server.yaml, or in other words, we develop a YAML for the web servers for all the configurations and the load balancing. Then we develop another YAML for the database servers, again for the load balancing and other kinds of services, pods and things like that. And apart from that, we will also have to develop a couple of other YAMLs for the front service and the back service, where we are hooking up the service, the internal service versus external service, opening the ports to the external world versus the private service for the internal world, and things like that. So in other words, this is a scenario of 3-tier architecture, but in real world, we will come across many scenarios where it's a multi-tier architecture. If it is just 3 or 4 layers and things like that, it's okay. 3 or 4 YAMLs is okay, but when you have multiple layers of architecture, then what will happen is that will get a little too cumbersome. It is also not very productive. It gets a little cumbersome, as simple as that, guys. So that's where the Helm comes to our rescue. Helm allows us to install all these YAML files, in other words, with just one single. It allows us to arrange these commands or the YAML files in such a way with one single command, we're able to install the applications, and with very minimal configuration, we can go ahead and specify the layers inside it, and Helm will take care of that. Okay, so an example is WordPress is a popular application, but there are tens and hundreds of such applications which could be deployed. So Helm is a package manager for Kubernetes. It's, in other words, package management software. It packages are called charts. They're like the packages of the in Python. Helm charts help define, install, and upgrade. So we can upgrade, we can install, we can the packages. Helm charts can be versioned, shared, and published. Again, a little bit of versioning and things like that can also be done, just so that we have an idea of the images that of the applications for troubleshooting purposes and things like that. Many times in production scenarios, the errors that we get may not be easy to reproduce. In such cases, the versioning comes to our rescue. Helm chart, pardon me. They can accept input parameter. So kubectl needs a template engine to do this. So there is something called customizing Jinja templating, which is generally done. We'll kind of try to get a look and a feel of it. Popular packages, again, lots of packages available. So here is ideally the Helm. If you go to hub.helm.com, these are the different kinds of charts which are already there. And let's say we search for something called Jenkins. That is like a package. So in one step, if you select that one, so here is WordPress, it will install. From the internet, it will go ahead and install. And we'll see how to specify the load balancing and other kinds of in a bit. So it's more precisely, Helm is a popular package manager is what it is. Okay. And let's see. So I think we may need to install Choco. We'll try to install Choco, and a little bit of documentation of how to install the thing is what we'll see. And let me know if the EKS cluster is up, Rahul. In the meantime, I'll make another one here.
Okay.
Okay, today we'll also try to get a feel of EKS logging. Oops, there you go. Okay. So, okay. So control plane logging and the worker nodes logging. In other words, control plane is the master logging versus worker nodes logging. Most of the time, we may not be interested in master logging because master logging is more precisely about the metadata and things like that. Masters are generally enterprise class servers. They don't really, we don't really need to troubleshoot them that much, but most of the times it's application logging, which we, or more precisely, the developers are interested in, because they're trying to understand what is happening in their application, what are the kind of requests they're getting, what are the problems and the troubleshooting stuff and things like that. They're mostly interested in the worker logging, which is nothing but the EKS worker nodes logging. So in the cluster that we are about to create, there are going to be 4 workers. We are going to look at the logging. Back to the control plane logging, we have K88, that is a Kubernetes logging. Audit, authenticator, controller, manager, scheduler. So these are nothing but more precisely, these are the components of the master. And what is that? Anything related to these things are ideally not really used by the applications of the developers. So we may not necessarily be interested that much, but most of the time, 90% of the time, it's the worker nodes logging that most of the time we are interested. So system logs from kubelet, kube, proxy, or Docker, or in other words, these are the lightweight process which are helping the EKS coordinate with the master and the worker. Application logs from application containers. Again, the logging from the containers, the pods and things like that gives the exact information on slightly more insightful information about what the application is, what was the status of the application is when they were specific issues and things like that. That is generally coming under the worker logging. So here, ideally, imagine there are 3 apps, 1, 2, and 3. One is in, let's say, violet or maybe purple. Another one is yellow color, app 2. And the light blue or maybe cyan is an app 3. So if we look at this one, we have different combinations. In different nodes, we will have different combinations of containers, pods, and things like that. Ideally, in a scenario when we have a large number of clusters or large number of nodes in a cluster, we don't dictate in this node, I want this kind of a pod or a container, but you just leave it to the cluster. Cluster will wherever it will do the work balancing, the data balancing, and it will bring up the containers wherever there is space available based on the utilization that is going on in the other nodes and things like that. So ideally here there is a different combination of the colors, which means different containers of the applications are working, different workers is what it is. Now, what is the problem is generally, if we have only a single node, imagine we take a single node. The EBS is elastic block storage. What is that? That is nothing but the hard drive, like a hard drive or an SSD of your node. The logging of the master and the worker is generally going to the log files in which is saved in the SSD. But most of the times, or sometimes, the worker nodes may be commodity servers, and where they do not guarantee. They do not have the guarantee on the uptime because they are commodities servers. They may fail anytime. So what will happen if the server fails is there is a good possibility that we may lose all the data inside it. We may not be able to recover, and you don't necessarily have to be in a stage where you don't recover. But even if you're in a stage where you are not able to access the data also, for real-time applications, that becomes a big problem, as Sev1 and things like that. In other words, we need to have the data always available. So if the instance is terminated, logs are gone. And from a slightly admin perspective, once they're terminated, they may just ship it out, and many other things can go on, guys. Okay, so that is where the cloud logging comes to the picture. The one we are looking at on the right-hand side, logs need to be aggregated in a meaningful way, or in other words, many times the nodes which are saving the logs to individual drives. So an application, for example, the yellow application that we are looking is running on node 2 and node 1 and node 2. Now, to understand what is happening about that yellow application, yellow colored box or the yellow colored pod of the application inside that one, we may need the logs from both the nodes. Ideally, what we'll do is we have to go to node 1 and we have to go to node 2 and get the logs. You have to read logs, aggregate them together, and we can write some scripts and things like that, but that is generally the process. And what will happen if you have 100 or 1000 nodes? Well, that will become, again, cumbersome, unproductive, and it may become very, very complex also. That's another problem generally we have if we are logging to the EBS, to the hard drive and things like that, okay? So let's see, that's where we bring in the logging. We are abstracting the logging. You take the logs. In other words, we can set up the logging in such a way that the containers, the pods, and the services, when they log, all their logging is actually going to maybe a cloud logging or something like that, which is like an Elasticsearch. And let's say, so that is generally the cloud logging. Containerized application writes to STD out and STD error. So in other words, Kubernetes, when there are errors and things like that, if it is configured in a normal way, it is writing out to STD out and STD error, which is not really captured unless we specifically configure it to save it to some log files, which is under var log, container start.log files and things like that. And they're all in different places. Containers log to one place, pods log to one place, service logs to another place. All these things could be in different places. And what we need is ideally a single point. We don't want to keep on looking at tens and tens of places for different kinds of logs and different endpoints and things like that. So So in other words, that is where the cloud logging comes from, the log backend, which is Elasticsearch, Splunk, CloudWatch, or a couple of other competitors and things like that. But that's where we can have a FluentD. So FluentD is kind of a logging agent. A logging agent means it's like a process, a daemon. It reads the logs and sends it to the logging backend. The logging backend could be Elasticsearch, Splunk, CloudWatch, and things like that. So FluentD is the logging agent we see. FluentBit is the cloud version of that. We'll look at the FluentD and we'll try to save it to the Elasticsearch. So Amazon gives us a simple way of configuring it to the publishing it to the Elasticsearch, guys. Okay, so there it is. The stream is nothing but real time. Since you guys are into the financial world, many times the stock prices and things like that are changing every few seconds to minutes and things like that, and that is being published to various parts of the applications of the people or the users around the world. What is that is streaming? That is where the Kinesis comes in. We can also have FluentD configured to other kinds of data sources such as Kinesis. Kinesis is for real-time data, and that will internally send it to the logging backends, which is like Elasticsearch or maybe Hadoop or other things like that. So EFK stack is about Elasticsearch, FluentD, and Kibana. Kibana is the dashboard, FluentD is the logging agent. Elasticsearch is the kind of a cloud logs in a slightly simple way is what we can think of, guys. Okay, so that's a little bit of theory. And let's see, any progress on that one, Rahul?
So it is still created.
Okay, still working. Okay, you can go ahead and share your screen, buddy. Let's have a quick look at it.
Okay.
Pardon me. It's deploying EKS rolling group waiting for cloud formation. Okay, so let me come back here. It's a cluster. Deployment. It's nothing but rolling. Okay, so in the meantime, actually, let me come back here. Let's see, cloud. I think let me cover a little bit more on the theory part of it. So,
okay,
share it. Say, here we go. On the cloud part, I will just cover a few of the things and so on, guys. So there it is, regions, short and sweet. They are nothing but a group of zones are nothing but they're a group of data centers is what you can think. A cloud computing model is nothing but a group of regions around the world. Is a simple way to think of it. And let's see, when we create resources, they're created in the data center. The cloud provider is responsible for the data center, for maintaining the data center. In other words, that is the advantage for the companies. The data center contains all the physical infrastructure required to host the resources. So in other words, again, data center has every thing. So that is a group of data centers that is nothing but a zone. And the data centers are generally connected via the low latency networks, which is nothing but very high-speed internet and things like that. So zones, these are physically separated locations within a region, or in other words, group of zones is a region. Each zone is made up of one or more data centers, a group of data centers. Each is equipped with independent power, cooling, and networking. In other words, these are things we don't need to worry. In a slightly enterprise world, these become very, very important that the companies maintain these things. And for the businesses, they don't need to worry about this kind of things. That is what the main advantage is. We can use the zones to run mission critical applications with high availability and low latency. In other words, businesses, let's say an application which is primarily based on e-commerce and things like that, they wouldn't even like to lose one order. And in terms of times like festivals and things like that, at any 1 minute or at any given period of time, when they offer special discounts and things like that, they get hundreds and thousands and tens and thousands of requests in just a few moments. And that is where the high availability and the high speed comes into the picture, and it becomes very, very important for the businesses not to miss those opportunities, because they make the money which is sufficient for their entire business in these few moments, rather rather than me. In other words, that a few 100,000 requests which are made in these few moments will run their business for 1 year or 2 years and things like that. That's generally what happens. So high availability is very, very important. So again, regions is nothing but a group of zones. For example, Microsoft has 54 regions and 140. What is that? In 140 countries, guys. Okay. So resource groups, again, a group of resources can be tagged together as resource group. They maintain the life cycle of the resources. Virtual network, again, you guys are probably already familiar, but let me just cover a little basics and prep you up for the Google Cloud. So it allows you to define your own network, virtual network. The network is not really there at a physical level. It is there at a virtual level, short and sweet. That's why we call it as virtual network. Virtual machines are hosted or created. That's what we are already doing. We can have multiple virtual networks, and networks consist of subnets. Subnets are like subnetworks. So if you
The cluster is ready.
okay, you can share it, please. And can you just do an LS, please? You have NG port. Can you do a cat on the rolling? And let's say you have an apps V1. The first one is deployment. And let's say how many replicas you have. Where is it? Replicas. Oh, you can change the replicas to 3, please. And while you're at it, let me also share you another file. Back here, it's the downloads. Here we go. Deployment. Now, copy this one. Okay, I'm going to copy this one, paste it in the chat window. You can save this and you can come out of this. Do a vi deployment.yaml. Paste it, copy and paste this one into the deployment.yaml.
Okay.
Okay, change the image nginx to 1.19 because it's specifically indicating. As simple as that. Save it. Let's go and say apply kubectl apply -f deployment.yaml. -f deployment.
Okay.
Yeah. Yes. Okay. Do a kubectl get all. Okay. We used t3.micro, right?
Yeah.
Okay. All right. Now mind. So notice, I think 2 of them are in running status and 1 of them is in container creating. That is because it is possible. I'm thinking it is going to wait for some time.
Yeah, it is.
Good. Okay. So I thought for a moment the minimum was 3. Okay, that's not bad. So there it is. 3 pods, 1 service, 1 deployment, and replica set. Everything looks good there. Okay. So let's say go back to the AWS console and go to the clusters. Just type in clusters.
Yeah.
There it is. I think we're already looking at it. CK rolling. Click on. And so click on the workloads configuration. Scroll down, please. So let's see, API server endpoint connect. Let's say that is a server endpoint, cluster IAM row. Can you just copy the server endpoint and just open it in a new browser, paste it? So the kind is, okay, server endpoint, forbidden, okay, that's okay. Somewhere here, the other endpoint is there, we should be able to access the engines, but let's see. Whatever, click on compute. Select that one, EKS nodes. We have 4 nodes, Kubernetes version, scroll down, details node, health issues, status, and things like that. So where are we? Look at, could you scroll up a little bit? We are using the version 1.19. AMI type, okay, looks good. Scroll up, please. Your current user. Node group information. Click on the info where it says node group information.
Yeah.
No.
Yeah.
Yeah. Okay. Guess manage node groups, deleting it. Then we have the node group configuration. Scroll down, please. Just click on nodes. Nothing there. Health issues. Labels and update config. Just go one after one. Still clean. Let me see. Next one. Maximum unavailable is 1 node. Kubernetes stands. Okay. I haven't really gone much into it. So now, let's say, scroll up. We are using 1.19. Actually, had we used a slightly old one, it would have given us an update. Scroll up, please. Now scroll up. Click back on EKS rolling. And let's see. If you notice there, the cluster is running the oldest version currently supported. Click on update now. And let's say select 1.2 and updating the version cannot be reversed. Let's say, what else? I think we can go ahead and update it. But before we do that, go ahead and update it. There isn't it? Click on the drop down one. Okay, that's okay.
It was showing only this 1.2. No other version was possible.
Yeah. So let's say come in. Is it completed? Now come back here. Go back to console and do get all. So 3 of them are running. We're updating the Kubernetes version, right? We need to describe. Let's say, do a describe on pods, kubectl, describe pods. Okay, so somewhere here, it should give us the, I think we can do a grep, but let's scroll up. First, we'll look at it manually. Oh, it's still running in engines images 1.19. Scroll up.
Actually, we have updated. This is the image version. That is the Kubernetes.
That's also a good one. And let's see.
Maybe we should run that EKS CTL command. Then we may file.
You're doing a describe on the pods, right?
Yeah.
Node group. It should just do a grep, pipe it out and grep it for 1.20. Pipe it and do a grep 1. Grep 1.20.
Oh, sorry.
Okay, instead of describe ports, do a describe services, the same thing. What else we have? Pod services. How about replica set RS? How about describe all? Grep for 1.19. Sorry about that. Okay, there is 1.19, that is image that we created. And let's say that's the first one, second one, third one, and the fourth one. Pulling image successfully pulled. Okay, container is Docker. Okay.
Maybe we should run that EKSCTL command to find out whether the cluster got updated or not.
Let's see. We have already done the update, right?
Don't notice they haven't shown any message.
One moment, let me see. Go back here.
Yeah, it will show here. It's still running this. It is still updating.
So there you go. It's still updating. Okay, good. So I guess we'll give it a few seconds here. Pardon me. And while that is coming up, let's see. It needs to become active. Coming update. And let's say if you go back to that one and just do a history, please. I just want to see the create command that you have given. We have given the node group name is EKS nodes. EKS-nodes. And so make a note of that one. Let's see what I have here. Pardon. Is it still on running? Can you just verify the status, please? Refresh.
Still updating.
It's going to take some time here. Okay. Can you do EKS kubectl get nodes? All of them are in ready, and they're still referring to version 1.1. -o white, get nodes -o white. So they say 60 minutes, all of them are 60 minutes, and kernel version, okay, was image. Trace of 1.20. Okay, I guess we'll just need to wait for that. Okay, so in the meantime, while that is coming up, I'll come back here. Let's also touch a little bit of, you need to install Choco. So let's say, can you bring up the browser and just go to helm.hub, I'm sorry, hub.helm, just type in hub.helm, HELM, yeah. Yep. And okay, introducing the Helm Hub. What I wanted to do is I want to install Choco and we're on AMI, right? Install, just say, okay, chocolatey. Yeah. Let's chocolatey directly. This is the GitHub. Scroll down. This documentation here. I'm going to install. Yeah, right click that. Say open new. And if you scroll down a little bit, there should be somewhere for Linux. I think we need to do a curl or something like that. From script, install it. So there it is. Get Helm. And just do a search on Control F and do a Choco. Choco installed Kubernetes Helm. Okay, but this is for Windows. So scroll down a little bit. From scope, you want from snap. I think we need snap. Scroll down. Sudo snap install Helm classic. Let me see. Okay, that'll take a little bit more time. Let me actually bring this up. I'm just verifying if Choco is really necessary for a Linux one. So just give me 1 minute. Okay, I'm going to send you something. Try this one, please. I'm pasting this in chat window.
Yeah. So this cluster got updated and it is showing update now.
Very good. Okay. Now yeah, we'll come back to that in a minute. Go ahead and do the curve. Save. Complete this and go like that.
Should I run?
Yeah, please run that. So Helm installed, okay, good one. And let's say paste this one, say run this one, check the version. Okay, good one. Then let's do also this one. Run it, please. I'll explain to you what that is. Okay, and here's the next one. And search repo stable. So, and these are all the stable charts or packages. And what we can do is we should be able to list them out. But before that one, Helm command. We're opening it. Okay, let's try. These are two things actually. Let me see. First, let me paste this one. No, this one. Come back here. Okay, we have checked the version, search repo. Just say Helm search repo, WordPress. Search space repo, WordPress. WordPress. Is it Helm's? Helm, H-E-L-M, sorry.
Okay.
So that is version. So what it is really doing is you also repeat the same thing and just type in Nginx, maybe Apache 2. What is it? How about Nginx? Okay, so we have Nginx Seagrass, Nginx Lego, then we have Cube Lego, deprecated. So we really don't have Nginx here. So what it is doing is it is giving a list of all the packages which are available. These are not installed in our machine here. They're available in the hub. Is really what it is about. Something to keep in mind. If you go back to hub.helm.sh now, hub.helm.sh. Go to Hub Buddy.
Yeah.
Hub.
Yeah. So
You just search for WordPress. Can spring them up. Enter. So these are all the charts and these are all the different versions available. Just type in Nginx, search for Nginx. Okay, so we have 1.21.6, 1.16.0 and things like that. Looks like we don't have maybe one.
So in short, why we use this Helm tool so that we don't need to write that configuration file.
Multiple YAML files. That is right. As simple as that. It's just a one-line install, and that's what we'll try to understand. Go back and say, go back to the console, and let's say what are we looking for? And let's say Helm search. Earlier you have given Helm search repo, right? Now say Helm search hub Nginx.
In terminal.
Yeah, in the terminal. Yeah, Helm search hub Nginx. So if you notice, we're getting a lot more options here. When you just say Helm search repo, it is the metadata of the repo which it downloads and keep it locally. It's something to be kept in mind. It is not that all packages are installed, but it is just the metadata it is keeping. Whereas when you explicitly say his hub, search hub, it is actually going to the cloud and checking for all the versions which are available for the Nginx. And notice
previously we were searching only locally.
previously it was only looking in the in the local metadata, which it
Okay.
installed it. Okay. And let's say, okay, now what we'll do, if you go back to the browser where you search the engines, if you still have it open, let's select, let's say, wow, that is 1.21. And somewhere here, they should give a pull, a link to pull it. Image, where is it? Helm chart. Helm chart. Click on the Helm chart on the right hand side. Q Prometheus. Engine.
After clicking Helm chart, it
Um,
shows different everything.
Can you scroll back, please? Somewhere they should give a command for pulling it. It's like,
Maybe we need to click here and
okay,
here somewhere they will.
good one. And let's say scroll down. So Helm install Bitnami engines, or I think look for pull. There should be a pull here somewhere. And Control F and pull. Image pull secrets. Just say Helm pull, Helm space pull, type in Bitnami/engines in your terminal.
There is, okay.
Back to terminal.
Okay.
Helm
Full
and Bitnami/engines, and then say space hyphen antar hyphen true
space hyphen and tar
hyphen true.
1, 2.
Yeah.
Enter.
Yes. Antar. What does it say? Unknown flag. Okay, remove the. Just say hyphen antar equals to true rather than hyphen. Okay. Bitnami not found. Isn't that what it was? Go back to the hub. So wait. charts.bitnami/engines. Helm install.
Maybe first need to add that there.
Actually, if you say pull, I don't think you need to add it. But okay, just go ahead and do that. Helm repo add. Next, let's go and say, I think we're calling it my release. Not pull. You'll need to install it. Helm install now. Because you added it, you install. You need to go back to the hub and copy that. Yeah. This is going to be called as my release. While the chart is being deployed, okay. Okay, do an LS. And where is it? Deployment bin. Do an LS LTR. So in other words, if it installs, we do not have the visibility into it. Can you do a Helm pull? Helm pull. Let's say engines. Enter. Non-absolute repo name /bar chart. What was the thing that you gave here? Do a history, please. You have given Bitnami /install. something changed here. Let's say when you executed exclamation 152, can you do exclamation 152? Helpful. Okay.
Yeah, now it is pulling.
Strange. Okay. Do an ls. Nginx. Yeah, looks like it created the directory lsltr. So Nginx, go into the directory Nginx and list it. And let's say there's a chart.yaml. CAD the chart.yaml. Chart, capital C. Okay, so let's say that's the containers, information, sources, maintenance, and categories, infrastructure, dependencies. This is 1.x.x. And let's say we're looking at LSLTR. Let's say we have a charts directory. Go into the templates directory. List it. LTR. Deployment.yaml. CAD the deployment.yaml. Okay, so if you notice here, this is what is Ginger templating. This is something to have an idea. You don't have to worry much about it. But what is Ginger templating doing is, it is the flower braces, wherever you see, it is dynamically going to inject the values here. We can just give a version and say 1.19 or 1.20, and it will automatically substitute those values. It is like the arguments that we are sending here. So what we'll do is CAD the deployment and grep for something called image. Okay. And so if you, wherever you are seeing that flower brackets, braces, that is where the version that we specify will be.
Okay.
Just type in kubectl get all. And we have two deployments. We have one service, load balancer and ELB. The load balancer, service my release Nginx. Yeah, so that created a load balancer. Now copy the external IP. Okay, paste it in a browser.
So we have deployed that Nginx and it is running. We can access it from the load balancer, right?
Yes, there you go.
And this is deployed using that help, right?
Yeah, exactly. So here we didn't have to create the YAML, complete YAML file, but mostly imagine a scenario where you're working in a company where they need to expose a product. Let's say Nginx is our product and we just wanted to, and we ended up creating a Helm package or a chart for that. In just one step, they're able to install it and up and running. Catching the point, Rahul?
Yeah, but what if we want to modify it like the way we want?
Then you'll need to do a little bit of debugging, or debugging in sense, you need to go back to deployment.yaml. You'll need to modify it and things like that. You will need to understand slight intricacies, go deep into it and try to do that one.
Okay.
It's a slightly deep one and a tough one. Okay.
Okay.
Yeah. Okay. So that's what I wanted to show you about the Helm. It's itself. How you do that is actually a very in-depth one, but I don't think we'll go into those aspects now. Rahul, we'll leave that for now. Okay. Do you want a 5-minute break?
Yes.
Okay. Okay. I also. Let me know when you're back, Rahul.
Yes, I'm
Okay. Pardon me. Next, we'll take a little bit of logging. We'll create another cluster also we'll have it get started. Say come back here. Okay. And what should we call this one? Okay, let's do an EKS CTL Git cluster. We have one. We'll keep it for a few minutes before we leave. We can delete this one. Let's say we'll create another one. We'll call this one. Let's say this is EKS rolling. So what I'm thinking is, okay, rather than creating a new one, let's dig into this one. Go back to the AWS and look for EKS rolling. Back to the cluster, EKS rolling. There, click on that one. And we just need to go into the instances of it. See, there's a direct link for the instances of the nodes. EKS nodes, click on that. Click on that. Then go to the nodes. Not much. Can you go back to EC2 instances? EKS rolling. Okay, there you go. We have 4 of them here. And 4 of them are, let's say, they're all given the same tag names. Select the first one, EKS rolling EKS nodes. Have you selected that?
Yes.
Then let's see. See if there is something called roles under this one. Scroll down.
The roles are
In settings, okay. Isn't it on the security? No, here in this one.
modify and
Pardon me?
yeah.
No. Cancel that one. So if you select that one and there's a security tab here, right in the middle. Scroll up. Yeah. And that is one. And let's see, we have security groups. IAM role, inbound rules. You just need to attach policies I'm looking for. Or just type in roles in the search window on the top in the console. And click on roles. Okay. And look for, I think the name is EKS rolling, I think, right? So just type in EKS rolling and EKS CTL cluster and the node group. So I think we need the node group. Select the node group. Start with the node group.
Node group.
Yeah.
This one.
Yeah. And if you scroll down, these are the permissions. Search for the permission CloudWatch. Type in CloudWatch. CloudWatch, CLOUD.
Maybe we should go to add permission. There we can find that role and we can add him.
Yeah. Let's say, yeah. Attach permissions. Yeah, first we need to attach the permission. And here we're searching for CloudWatch logs. And CloudWatch logs, I think it is full access. We can attach it. CloudWatch logs full access. Have you attached it? Yeah, attach it. Policy was successfully attached. Okay. Now I think what we need to do is we have attached it to the. So the CloudWatch logs is another service which is actually looking at the nodes, the node groups, which is nothing but all the worker nodes, and it is reading from their EBS, the elastic block storage, which is generally either the hard drive or the SSDs attached to it and things like that, and showing us the log files. But remember, the problem is we will, if the node goes down, then we wouldn't have access to that one. The CloudWatch logs will not be able to fetch the logs. That is something to be kept in mind. Okay. Let's see. Now I think we'll have to apply a log here. We also will not create a separate cluster because we'll have to wait. So back to terminal. Let me go back to and see. Create a file called fluentd.yaml. Fluentd. Here we go. I'm going to copy this one. I'll send it to you. Chat it. Right. One more time. Paste it. Paste it. Oh, I think it's not taking it. Slightly large file. Let me upload it to the G drive. Try to access the G drive. So let's see. Come back in. Upload a file. It's fluentd.yaml. Set up file upload. And remember the name of the file. Remember the name of the cluster. Here's the first one. Just upload it. If you refresh, you should be download the file. Just cat it after you download it, or in other words, you can open the file and just copy it and paste it into the VI. Okay. So if you look here, this is all the fluentd information. This is going to act as an agent for logging and things like that. We'll have to apply it. So copy this one. And before you copy this one, I think we need to update the name here. Search for, back to the fluentd.yaml in code, and search for name and region. Name first, fluentd is okay. Environment. We are looking for region. Search for, search for env first. env, small env. There is a key called env under which there is a region and things like that. So go to the next one. So this is match. Here we go. Name. What is our region?
The region is our US East group.
Change that value to that one. And whatever is the name of the cluster, wait.
I'm very confused.
Oh, so under the cluster name value, we need to update the name of the cluster to whatever the name we have given. I think no. That is the key. Cluster name is the key. The value is what we need to update.
Okay.
Just verify the name. Is it EKS rolling or what it is? But we just
actually case rolling.
Go ahead and update it. Yeah, EKS rolling. Let's see. EKS rolling. I think that should be it. The rest of it is Fluentd. Save it, copy this one and paste it into your VI. Save and quit. Then apply the fluentd.yaml. Yeah. So you're getting RBAC authorization warning. Damon said CloudWatch created. Okay. And if you say kubectl get all, so 2 replica sets, and we have pods, jinx and things like that. About get pods -o white. Pardon me. So let's say we have IP readiness case nominated node, internals nominated row. No. What am I looking for here? Kube system. Not that. We have applied the Fluentd. Okay. Now go back to the console and search for, in a new window, search for logs or log. Just search logs. Yeah, enter. And see what all is coming up. Under CloudWatch, there is logs. Click on that. Click on log groups. Okay, click on continuous and expire. Only one log group. And scroll down, please. Log streams. Okay. Click on the first one. So this is information that it is logging into the EBS or the hard drive and things like that. We are able to see this one. We have attached the
So this is this got created after running that Fluentd.yaml.
So the Fluentd agent, using the Fluentd agent, since we applied it, we are now able to see these things in the CloudWatch. So what is happening is if you go back one step, which is go back. So notice, So notice how many log streams are there. In each log stream, all these things are separate and things like that, right? And all these things are hooked up onto, what do we say, onto the hard drive is what it is. That is what it is. That's a major thing. Short and sweet is what it is. But let's say, scroll down here. Oh, I think load balancer. Cube system proxy, Nginx and things like that. So Fluentd CloudWatch is the one that we were interested in. And next one is load balancer. Like Fluentd, okay. Next, in your list, if you go to the terminal and just do a list and see if we have created a file called load balancer. Where's your screen? Do we have a load balancer on Fluentd? No, scroll up one step higher. I think you were in the no. CD dot parent directory. Okay, now you do a list. Oh, what is it? Just do a CD and list it. Achha, we are right here. So ng cat the ng-lb.yaml. API version, one moment. Let me see. We have a kindness deployment, front-end deployment. And let's see. We're starting with the deployment here. So scroll down, please. Oh, that's it. Scroll up. I thought this was starting. Okay, scroll up, please, a little bit up where it starts. Okay, so it's a service, it's an LB service, and port is 80, front end. And then we have replicas too. Minimum seconds is, so scroll down, please. Rolling update, Nginx is the image. Replicas is 2. Load balance. Okay, let's go ahead and apply the load balancer also. ng-lb kubectl apply. Okay, so again verifying get all, kubectl get all. So we do have front-end deployment and I release deployment.apps and things like that.
Still in pending.
Pardon me? Oh, it's still pending. Give it a moment here. This for load. Let's see, come back and let me see how this looks. This could be a problem. Copy this one. How many lines is this? 40 lines. I'm going to give you another one. Control C. Let's see if I'm able to paste this one. 18. I pasted another YAML file. Can you try say vi and so save this one, come back here. What shall we call this? We'll call this as K8s hyphen log dot YAML. K8s hyphen log dot. Yeah. Here's the one that I sent you. Okay. And right and quit and apply this one. Oops, what did I do? Yeah, so service and deployment this here. Have we done it? Let's see. Get all, yeah. Okay, so we have hello K8 is running. And
we don't have capacity to run this.
pardon me?
Maybe we don't have this capacity to run this much. That's why it is showing on the screen or all the new control.
Gotcha. These things are running in pending state. Okay. Okay. Have we done a mistake? Maybe we should have gone for m5.launch. All of them are in pending. Oh boy. Can you do a get cluster? You can see till get cluster. Oh, well, we have only one, and it's on t3.micro. Okay, do one thing. Since we're going to be stuck with this one, go back to the log groups. Log groups, and we refresh this one. There's a CloudWatch and cube system. Have we done an apply? Yeah, we did an apply. And what was the name of it that we have given for K8s? If you look at in the
K8
Fluently. Oh, these are all pending, so it won't come here. Front-end container. I guess we will need to redo these steps for using m5.large.
Yes.
So what we'll do is, Rahul, do you think what we need to do is we need to create the cluster?
Yeah.
Let's do this one, Rahul. Let's go and delete this cluster and
Okay.
we'll create the cluster with m5.large and we'll move on to GCP stuff and then we'll revisit this one. Okay. So, yeah. Pardon me. Okay. So them. And come back here. A few of them uncover here. These things need to be home. See where that is. Rahul, please take a 5-minute break. I need to just step out here for a moment. Sorry about that.
Okay.
Rahul, I'm back, buddy, just in case you're back.
Yes.
Amira, Sumit, Nitish, are you back, guys? Just checking. Okay, thank you. Sorry about that, guys. So I'm going to get started with a little bit of Google Cloud fundamentals. Say, come here. This here. There you go. So, share the screen. Okay. So let's see what we have. And in the meantime, go ahead and log into the Google Cloud from your side, Rahul. So here is a footprint of Google, different kinds of regions. Again, at a conceptual level, again, it is nothing but a group of regions, zones, and data centers, guys. These are some of the major regions of the Google footprint, and they are continuing to grow. 20 regions, 61 zones, network edge locations, countries and territories, 200 plus available countries. In other words, from 200 countries, we're able to access any of the services is what it really refers to. At a slightly higher level, the Google Cloud is nothing but it is a combination of compute, storage, and network. On top of it, the database, data and analytics, AI, and machine learning. This is where all the money is. These are the additional services they are performing, or in other words, they are providing. For compute, we have the computation aspect of it. Storage is where we are storing the data. Network is nothing but the networking, creating the virtual networks, private networks, subnets, and things like that, guys. Okay. Database is database, pretty straightforward. Data and analytics is again, it is slightly used interchangeably with AI and machine learning and deep learning today. That's where most of the money is today, guys. That's what everybody is trying to play and understand and trying to get insights and so on. Apart from that, the security is taken care of from the compute point of view, database, AI point of view, also from the hybrid and the multi-cloud. In other words, most of the times, businesses or the enterprises may need to end up working partially with the Google Cloud, partially with Amazon, and partially with Microsoft. In other words, any one or two, or maybe all the three of them. That's where the hybrid and multi-cloud comes into the picture. That's where lots of tools are being developed. And again, that's a big place or a big point where a lot of money is. Okay. API management, Google allows us to manage, or in other words, access the APIs of different services. API means just like a service, we're able to reach the endpoint and give it some data or access the data. And behind the scenes, it will perform all its complex things and give us back the output is what it is. We also have Google has its own set of Devops tools and things like that. We'll slightly touch. They are slightly similar to the AWS or the Devops tools in general. So management tools is where we are monitoring everything. We can monitor everything and every aspect of it is slightly at a management level. If you dig a little bit deep into the compute services, compute engine is where we will write the code. And we will, in other words, more precisely, we will develop an application and we will deploy it in compute engine. And that is where how we deploy and take care of that. Or in other words, once you deploy it in compute engine, our application will be run. That compute engine is nothing but the computation aspect of the Google Cloud. App engine is where already developed apps, generally the third-party apps and things like that, when they develop, they deploy it in App Engine and they try to sell and resell to various customers and things like that. Okay. Kubernetes engine is our orchestration engine. We have talked in detail and spent some good amount of time. Container is container registry is where with GCR. So that's where the Google maintains its own set of containers, and that is referred as registry. Then cloud functions is the Lambda functions and things like that. We're here to talk about that, guys. Okay. Here is the storage and the database aspect of it. The cloud storage is where we store all the data in the form of buckets and things like that. Cloud Big Table, it is the big data solution to store big data in the form of a structure, not in the form of structured data, but in a NoSQL. For NoSQL purposes, NoSQL stands for not only SQL. Again, we will not go into all those details. But when Cloud Big Table is a solution for the big data provided by the Google is what you can think. Cloud Data Store From what I recall, I think it is the RDBMS or the data warehousing. Cloud SQL again is another big data solution where we can write the SQL queries and try to access large amounts of data. Spanner, data store, cloud data store and Spanner, one of them is purely is used purely for RDBMS versus the data warehousing. We'll talk a little bit about these things in the coming up slides. Persistent disk is again, we take additional drives, and these disks are highly available and things like that. So we try to separate our application from the data. These could also be the data taken from a database and stored to persistent disks as backups or maybe as live data also. Then the networking component contains the cloud virtual network. The virtual network is not physical network, but it's somewhere on the cloud. So we call that as a virtual network, and only we can dictate the access to it so that not all the traffic which goes through the internet goes through that and things like that. Cloud load balancing. Load balancing is load balancing. We have talked in brief here and there. We touched it. It's about balancing the request to the multiple servers and the process of scaling out the applications, guys. Okay. CDN, the cloud CDN, distributed network. What is that? Code distributed network, something like that is there, guys. So in other words, we developed an application in USA, but let's say more than in USA, in other parts of the world, in other continents of the world, people are more accessing this application. In that case, we would like to maintain a copy of this deployment in other parts of the regions or the zones of the world. That is what is the distributed network is. Cloud distributed network is about. It will allow the code so that the performance for the other parts of the world is fast. Cloud interconnect, again, it is nothing but the connecting the network. DNS, again, the route tables and things like that. We'll briefly touch them, guys. Okay. Security and identity. So cloud IAM is similar to the AWS IAM. Resource manager, it's used for monitoring the resources. Security scanner, again, for something related to security. Platform security is also related to security. I have not really looked much into it, but just rough idea, guys. Okay. Then AI and machine learning, the biggest thing, this is where all the money is, guys, to be more precise. Machine learning, that is what everybody is trying to understand today. If we have the data. So in most of the times, a lot of companies, what they're doing is they're actually looking at these log files and trying to make some sense out of it using the machine learning. They're trying to identify some hidden patterns in these log files and try to sell that insights. They understand insight, they make a product out of it, and they try to sell that product to various companies around the world. Vision API is for identifying whether a cat is a cat or dog is a dog or what kind of an animal and things like that. Speech API is for converting text to speech, speech to text. Natural languages, again, a big one. Trying to understand the unstructured text. Unstructured text is plain text. And trying to understand what they are talking about, what is the intention, are they planning to purchase maybe a new product such as shoes, maybe Nike, Reebok. So all that kind of insights, which is generally there in our WhatsApp messages, in email messages, that's where the natural language processing comes in. If you go to google.com and just type in how, it is automatically kind of giving an indication of how are you. How does it do that? Well, that is where the natural language processing comes into the picture. Translation API is converting from one language to another language. Jobs API, again, is another one for applying jobs, and it will connect to different job boards and download the data and give it to us. And there is the development tools, Devops tools. Cloud SDK, deployment manager, like code build, code deploy, and things like that. These are the things. We'll briefly talk about them. Management tools, again, these are some of the logging and other kinds of tracing and things like that. The billing apps and so on. Almost everything that we touch in Google may end up being a resource. If it's a resource, may end up being a billable. That's what the resource managers are about. So what we want to do is we want to kind of keep an eye, keep a track. Keep an eye and keep a track on these things, guys. Okay, so that's where the management tools come into picture. These are the other services, again, API Analytics, IoT Core. That's more about analytics and big data. All the IoT is nothing but Internet of Things, guys. All the sensors data, the modern smart cities, anything smart has data associated with that. And using the data, we can try to find the patterns So if you look at your own phones, you may be able to find a lot of patterns, but it is very difficult if you manually look at it. That's where the analytics and the data come together. VPN, virtual private network, AutoML is auto machine learning. Again, part of what data scientists do and things like that. These are the other services, guys. Okay. So short and sweet, GCP has a global footprint spanning all the continents. GCP includes core infrastructure, database, analytics, AI, and more. So in other words, anybody who's dealing with the data is today looking into the world of analytics and AI, guys. Okay. The platform has over 100 services spanning IaaS, PaaS, and SS. So just like AWS, it is trying to compete. It is not yet there compared to the AWS. It might take a few years, but definitely GCP is also being looked at as a strong competitor for AWS, guys. Okay. So that is a free tire. And I think yesterday we went ahead and created, Rahul went ahead and created username or an account. So GCP resources are the fundamental concepts of GCPs. So GC is global compute engine, GA is global app engine, guys. So Google Compute Engine provides the VMs, app engine also gives us the VMs and the instances. Then we have publish and subscribe storage buckets, objects, and things like that. Resources belong to a project. So at a slightly high level, we create a project. Under the project, many kinds of resources exist. So if you want to understand, get a snapshot of all the resources and the projects, then we ideally start with the project and look under it, and we are billable under project. We can try to understand, slice and dice, what are the resources, what are the billable resources, non-billable resources, and we try to get a feel of it. That's why it's slightly important to keep an idea, to have an idea. Projects may be organized into a folder. So project is a group of folders, just like any other. You can think of project like a parent folder. Project represents a billable unit. As I said, projects have many resources. Anytime something is created as a resource and Google Cloud treats that as a resource, that is generally billable, guys. Okay. Folders provide logical grouping of projects. So again, that's nothing but a group of documents together. Folders belong to one and only one organization. So in other words, more precisely, each project is generally separated into one organization, is really what it means to. An organization in the top level entity in GCP hierarchy. In other words, there is organization. Under the organization, we're creating multiple folders. Under each folder, we're creating multiple projects. Under each project, multiple resources are used. The resources may be a human resource or even a server resource or any other kind of resource. So at a slightly high level, that is what it is, guys. Okay. So Google Compute Platform. So this is how it looks like when you go into Google, the development, my first project, these are nothing but the folders and the projects. So we can have multiple projects and we try to save our files in these things, guys. Okay. So let's say, see what I have here. GCP shell. Okay. Rahul, can you go back to the GCP and try to access the shell, please?
Yes.
Pardon me. Sorry about that. Open in a new window. Just increase the font size, please. Pardon me. Okay, just do a history. Let's see if it's still as a history from yesterday. We haven't really done much. Okay, so do exclamation 3. Authorize. Or it can be sent temporarily. So, the required property is not currently set. It can be set on per command. I set it on config. Set per command. I think you need to select the project, I think, there, buddy. So what you do is, we haven't created a project, I think. Or yesterday we were able to look at the regions list with the project, rerunning your command with the project. Okay. Yesterday, I think something like 80, my project 8820. It's already selected. Put it in double quotes, my project 80.
Yeah.
So let's visit valid project ID. We go back and just type in projects, anything. Okay. Go back to the previous window, search for projects. Select a project right there. Okay. Cancel this one.
What should I do?
Cancel it, buddy.
Yeah.
Why does it have fluent cyclist 347806? Is this, did we create this one yesterday, Rahul?
Yes, we have created this project yesterday.
Which needs to be pasted. Okay, please do that. Can you paste that project ID as fluent cyclist after the hyphen? Sorry, there you go. Fluent cyclist or something is there, no?
Yeah.
Okay.
We recognize.
It's VM instances. Okay. So regions change. Let's try to create a new instance and see if you're having like remove project ID. What do you do?
Sorry.
From that command, remove that project _ ID. Try doing that.
Sorry.
Project _ ID.
I don't think you need double quote. Pleasure property. Okay. And do a cloud regions list, G-cloud. Okay, there you go. Thank you, Shishir. And let's see what it's been. Okay. So try creating an instance, Rahul. You can go to the search on the top and just type in instances.
Should I go to this VM instance?
Yes, VM instances. Create instance. Choose any region, maybe South, maybe South. General purpose is okay, and under the series, I think that we're going to generate. So the first generation. Yeah, first generation, no. And I think there is something called f3.micro something. f1.micro, yeah. Okay, and What is the total is 5.85, okay. Allow default access, scroll down. Allow HTTP traffic, the first checkbox. Yeah, and equivalent command line. Okay, strange. Then I think, have you clicked on the create?
Yes, should I click?
Let me just verify. Yes, click it, please. So back.
I'm giving this error again.
Does not have enough resources available to fulfill the request. Try different zone or try again later. Oh, just use a different zone, buddy. Just use US East 1A or something like that. I don't know why they wouldn't have.
I will use this default.
Yeah. Pardon me. Allow HTTP traffic.
Yes.
Okay.
Should I click this?
Yes. Okay. Yeah, expand it and see it's saying running. No. There's an SSH, I think there's another SSH. You can also do that, but before you do that, go back to shell and say G Cloud Compute Instances List. Instances list. And let's say, remember the zone is US first for B. Zone. So let's say G Cloud Compute SSH. G Cloud Compute SSH instance -1 -- zone is whatever that zone is, US West 4B. Okay, and I think, yeah.
Enter.
Yeah. Yeah. Yes, empty for no passages. No, empty. Just press enter. Enter again. Just the same as the general things that we do. Okay. So now we have SSH into that one, and our username is Rahul Gupta. Okay, that would be generally easy to use. So let's go ahead and do sudo apt get apt-get update. Hyphen, no space. Okay, let's go to moment.
This one is Debian. We haven't changed the.
Pardon me?
This image we have used is Debian one, the OS.
Okay.
But the command got ran correct.
Oh, okay. Yeah, as long as we're connecting, we're okay, Rahul. Let's say we'll install Apache 2, say sudo apt-get apt-get install -y let's say Apache 2.
Yep.
So ideally, inside the engines in the Apache 2, we can plug in whatever applications we want, as long as they're installed properly in containers or Dockers. They're ready to be exposable, to the world. Catching it, buddy?
Yeah.
Okay. And I think we also need to sudo systemctl so come here. What do we do? Oh, sorry about that. VMware git bash, yes. Yeah. We'll do that. Also, okay. That's what we've been already doing using the AWS. So I'm just for a change doing this one. Systems.apache 2, buddy.
Start.
Yes, Apache 2. Okay, so now I think we should be able to access the Apache 2. So what you do is go to the instance and find the external IP. Go back to the console. So here's the external IP. Copy that one. I think that should be cool.
Yeah.
Okay. So that is.
But sir, how we will connect from our Gitbash? We don't have that key. Key now we require maybe key or maybe username and password.
There's a place where we can create the key. Let's say in browser we use another client. Click do a use on no. Simply provide private access. Use another SSH client. Connecting to Linux VMs. So I think we'll need follow this. I didn't really go through. I was just connecting through this one. because I wanted to give some useful introduction. But if you just go through the steps, we should be able to somewhere come along. I think how to create a key and do download of that one also. We'll see that. We'll see that also. Okay. SSH keys. Gotcha.
एडिट करके देख ऊपर 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 हाँ ऐड 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 आइटम नाम दे दे but then how will you download it? Okay.
Key require format
Somewhere. Just give me one. I'm looking to
I think you should create a new instance and see if you can download the SSH key there. Moin says we have add key during the VM creation, I guess.
yeah.
Something was downloaded, Rahul?
No. Actually, we haven't set any key name and anything like that, and haven't downloaded any file.
Yeah, we haven't done it here, but
Maybe we can try by creating new VM and see whether there is
New
option.
instance.
hold on one second. I'm also looking at it.
Okay.
Let's see. Science. See. Let me share this with you. This. Oops. Okay. Here's the link, Rahul. Just click on the link. Let's follow a few steps.
Yeah.
So there is Linux and Mac, right?
But this is different one. This will generate one key, and this is for the passwordless which we use.
determines the keygen. Isn't that what you're asking?
No, actually, it's different maybe. Next source expression is B1. The following one.
Try creating new VM. Na?
Yeah, we can maybe try new.
Okay. Go ahead, Rahul. Sorry about that. Your SSH key session.
Maybe we need to first create.
Doesn't
Just not creating here. Maybe we need to create, then we can use.
राहुल थोड़ा सा ऊपर करो वो कंसोल में.
हाँ.
थोड़ा सा ऊपर कर. हाँ बस ये ग्रीन टी वाला ना लर्न मोर कर. Your SSH keys are generated automatically when you connect to a VM using this console or G Cloud. Your SSH keys generated automatically. नीचे देख. Use the SSH button in this. The public is stored in the browser session. Okay. ऊपर जा. थर्ड पार्टी टूल्स पे क्लिक कर. हाँ, see create SSH key for details. ओ भाई, lengthy process है.
Because then maybe we need to run this command first in a cloud shell.
But ideally, it should not be like this. No?
Yeah, it should. When we use Amazon or Azure, it will create at that time when we create instance.
yeah. Let's say public key for user flow. Okay. What we'll probably do is we'll probably look at this later. Today I'll look into this one. You also try to look into this one, Rahul.
Yeah.
I think we'll continue with the Google G Cloud console.
Okay. Which we could edit add item, text box, add your public key in a text box. add your public key in the tags. Maybe when here it is asking to paste that our key. The key must be created manually, then paste here, like something like that.
अच्छा एक काम कर सकता है,
Hmm.
कॉपी दैट फॉर्मेट ना, की नेम और यूजर नेम.
Hmm. एक
दूसरा और हाँ, की नेम स्पेस यूजर नेम.
हाँ हाँ बरोबर. Key name space username.
यूजर नेम बस.
And format of the key with the
नहीं
expiry.
नहीं, इतना डाल के देख सिर्फ.
हाँ बस.
की नेम स्पेस जीसीपी एडमिन है. बाहर क्लिक कर. डॉट की शेड डाल. डॉट की फॉर्मेट है क्या कुछ?
इधर
तो पब्लिक
key value, the public
की
key
वैल्यू.
value.
की वैल्यू
Username message.
नहीं, बहुत लेंदी प्रोसेस है ये.
Too different from AWS and AWS. Okay, so maybe we need to look into this.
Try to look into this offline, Ravi.
Yeah. Okay. I will cancel this one.
Yeah. And let's see. Let me share back to a little bit of theory. Share it back.
Should I stop?
Yeah, stop it. I'm sharing. Okay, some few things to be kept in mind. Compute services are a critical component of the cloud. So in other words, the computation aspect of it, code is deployed and executed in one of these services. In other words, the code is generally the application that we are at our end. And we have App Engine, Compute Engine. We briefly discussed about them. So we're going to go. Okay. So App Engine, one of the first compute services from Google. It's a platform as service. It's a fully managed platform for deploying web apps at scale and supports multiple languages. Comes into environments, standard and flexible. Applications deployed in standard environment run in a sandbox. Sandbox means it's its own set of environment at a slightly virtual machine level or virtual instance level that's separated and things like that. Before the world of containers and Dockers, the sandbox was a popular term, which was every developer's machine was like a sandbox is what they used to refer, guys, okay? But Dockers and containers made it at a much more microscopic level. What was it, a macroscopic level as a sandbox. So flexible environment uses Docker containers to deploy and scale ups. In other words, with the arrival of the containers, everybody started using containers because within a sandbox, we can use multiple containers and things like that and do the scaling. Compute Engine, again, enables Linux, Windows VMs to run on the Google's infrastructure. And VMs are based on the machine types with varied CPU and RAM, which means you can get different kinds of combinations of CPU and RAM. Persistence is available through standard and SSD disks, which means you can directly plug into the hard drives of the VMs of the instances. You can also add additional, just like AWS. VMs are charged a minimum of 1 minute and 1 second increments after that. And sustained use of discounts are offered for running VMs for a significant portion of billing a month. In other words, more precisely, the sustained use means whatever you use, you're paying. Committed use means you're kind of pre-purchasing for the next 1 year or for the next 3 years. And generally businesses and enterprises, they will go and buy for 1 year or 3 years so that they'll get some discounts, they can save the money and they don't have to worry about the combinations of availability of the resources, and many other reasons are there from a slightly billing and a management perspective, guys, okay? So that's a little bit about Compute Engine. Kubernetes Engine, we already talked about it. It's nothing but the orchestration engine. And it is a managed environment for deploying containerized applications. We know the control plane worker nodes, and GKE provisions worker nodes as a GC. So originally Kubernetes is coming from Google, But Amazon, everybody, since AWS is more popular and the most popular, everybody are using the Kubernetes on AWS rather than on Google, guys. But otherwise, most of the principles will be the same using the Kubernetes. It's just a few installation steps which you'll need to dig into it and try to, which will vary here and there, just like how we are using the console and the Git bash, guys. Okay. Node pools enable mixing and matching. Node pools is nothing but the node groups, a group of nodes again. The service is tightly integrated with GCP, which means just like all the AWS, you take any AWS service, it is integrated with other AWS services, which means it works properly with other AWS services. Here also Google Kubernetes will also work with all the other services provided by the Google Cloud. Scaling, upgrades, auto repair, all of these things are taken care of by the GKE. Okay. Cloud functions is nothing but the Lambda functions, is what we call in our AWS world. It's a serverless environment for building the and connecting the cloud. So in other words, we don't worry about the environment. We don't build the environment. We test locally in our development environment, and we take the code individually, and we try to deploy it on the cloud. And we are not worried about a dedicated use of it. So most of the times it comes to a rescue when we have events and triggers. When certain thing happens at a hardware level or maybe at a data level, we want these Lambda functions to be hooked up offline, and maybe we want to do some batch processing and things like that. That's where it saves a lot of money also, guys. Okay. Again, I'll talk a little bit about it in the later. So serverless compute environments execute code in response to an event. Again, it's event based. When a certain event happens, you go out and try to fire up the Lambda services. Cloud functions, you can write the clouds and cloud functions in JavaScript, Java, Python, and Go, and any other language also. GCP events fire a cloud function through a trigger. So trigger is again, when you write a Lambda function, when you observe something happen, you can hook up a trigger. You may want another Lambda function to fire off. So that is what where the triggers come to your rescue. An example event includes adding an object to a storage bucket. So we're adding something to storage. So again, the bucket is same as that is in Amazon S3. Trigger connects the event to the function. In other words, when somebody uploads an image, let's say we want to get a thumbnail of that image. So what is happening? Uploading an image to maybe a bucket is what is an event. And when the event is happens, you trigger something else. You want to take that image, you want to create a thumbnail. That is what the trigger is doing. Trigger will trigger the Lambda function as one way to think of it, guys. Okay. So that's our Google Cloud. And let's say I come back here. See what else we have. Oops. VM instances. We just created a VM instance, and have you created the VM instance, or have you backed out, Rahul?
We have already created one instance and connected using that cloud shell, but not created the second.
Okay, yeah, I think we brought up the Apache too, right?
Yes.
Okay. So let's see what else I have. Let me come back here from here. Oops. Repetition. Discuss about this. Okay. Choice of compute. Next, the storage services is there. Let me see what I can do. Okay. Let's take an example of a storage service. Can you bring up your screen now, please? Maybe last exercise for today.
Yes.
And type in storage. Yeah, cloud storage. We can give create a bucket. Just give any name, just say Rahul bucket 1 or bucket 1. Okay, expand that. Choose where to store your data. I think we can just select a single region. The third one. And choose a default storage class. Standard is good. Standard is generally the standard access. Nearline is for backups and things like that. Cold line is for cold data. In other words, standard is hot data. Nearline is okay. Backups is way. Backups also you don't. You do it maybe once a day, once a week, and things like that. Cold line is cold data. In other words, not once in a quarter and things like that. Archive is maybe once a year, as simple as that. Those are some things to be kept in mind. Okay, so for now, we'll say standard. Click on that one. And here we'll say enforce public access prevention and access control is uniform. Okay, that's okay. You can leave the default. Next, choose how to protect the object data. Okay, none is okay. Encryption. I think that should be okay. Just say create. Give moment. Now we have to, yeah, the bucket is created. You can, you should be able to create a folder. Just create a folder called images or something like that. Create a folder instead of upload. Images. And go into that images folder and just upload a file. So in other words, short and sweet, not much, nothing much here. It's just that you're creating a bucket. Bucket is acting like a drive itself. Under the drive, we have various kinds of files and things like that. So yeah, you can upload just a sample file or maybe an image if you have anything. Just upload a sample file. That's all. That's okay. Okay, as simple as that. Just click on that. Because all the, so just in case we want to set up the roles and things like that, also it is possible. And there is image, as simple as that. Okay. And okay. Then I think we have the storage things. Okay. So what I'll do is for today, I'll stop it here. Rahul.
So can we access this over internet?
Pardon me? Yeah.
Can we access this over internet? Like we used to upload on the
image.
Yeah.
You should be able to access it. But I think when we created, we didn't give the public access, I think. There is something called public access. Let's say public URL. See, public URL is not applicable there. So click on edit metadata. And scroll down, choose metadata, cancel. Okay, no, not this one. Cancel this one. Public access is not public at the time of creating. So creating the bucket, we did not enable that one if you recall. Let's say edit access. There's something called edit access here. So we did not enable the bucket for public access. I think if we create another bucket, I think we should be able to get an option.
Yeah.
And let's say nothing. Okay, look at, oh, let's see. Request to paste, access control is uniform. We can edit that. Public access prevention. Oh, it's not. Click on the access control. It's uniform, fine grained. I don't think that'll help. I think at the time of creating the bucket only, you can try to create another bucket and just play around the problem.
Yeah.
Okay. There you go. Principals roles. Public access. At the time of creating the public bucket only, we have to decide, I think.
prevent public access पे click करेगा.
Prevent.
Revoke करना.
Maybe we should do it at the time of.
Okay.
But there must be some option like from where we can enable or disable that public.
I think at the time of creating the bucket, you are given that option. No, I don't know at a file level you are given, but at a bucket level, I think you are given, Rahul. It's inheriting the bucket permissions, looks like.
Go to permissions. Prevent public access पे click कर. नहीं permissions पर bucket में जा. हाँ bucket permissions. Add है ना permission add. हाँ. कर नाम दे कुछ. Select role. एडमिन करके कुछ होगा. क्लाउड स्टोरेज है. क्लाउड स्टोरेज एडमिन. कर एक बार क्लिक कर. अच्छा एसोसिएट.
I think it's expecting an email address here.
Yeah.
ऐड कंडीशन नहीं छोड़ इसको. ब्लैंक छोड़ कैंसिल कर. Principals field all users object viewer. Okay. New principal all users link based out specific. चैट में लिंक दिया वो देख.
Cool. Rahul, you look into this, buddy.
Okay.
Today I'll wrap it up here. We'll continue the journey tomorrow. I'm sorry, guys. There is a slight change. I may not be able to take tomorrow also because we have a client visit going on and we are presenting a project and things like that. So I will be knowing about it only at the end of the day. In case I'm not able to take it, I will be updating you, Rahul. You just inform the team and things like that.
Okay.
There's a good chance we have to, we may not meet tomorrow and we'll meet again on Monday. Okay? Just giving a hand. I will confirm to you. Okay?
Okay.
Sorry about that.
Okay. Thank you.
Signing off for today. You guys stay safe and keep learning.
Okay.